Alrighty, welcome to this video. I hope you're having a good day. In this video we're going to be looking and using Wireshark, doing a basic network analysis. So we'll be looking at a few different types of protocols, so like ICMP, SSH, DHCP, DNS and RDP. So what we'll be doing is we'll be creating some virtual machines. So if you haven't done that yet, I would say go to Microsoft Azure and create yourself 2 virtual machines, and then we'll be good to go. If you need to know how to do that, then there will be a link in the description to a video where I kind of walk through how to create 2 virtual machines in Azure, and those are the ones that you're required to make for this walkthrough. So here we are in Azure. So what we're going to do first is go to our virtual machines, which I've made here ready to go. I've made 2 machines. The first one is a Windows machine and the second is an Ubuntu server. So what we're going to need to know from these machines is our public IP addresses, and then also the private IP addresses in order to be able to ping and communicate with each other. So firstly, let's figure out what our Windows private IP address is. And as we can see here, it's 10.0.0.4, and we'll see our Ubuntu one. I'm going to guess it's .5. Yes, so it's a 10.0.0.5. So with this, we will then go into remote desktop connection if you're using Windows, or Microsoft Remote Desktop if you're using Mac. I'm using Mac, so that's what I'm going to be using. And we're going to want to copy this public IP address to the clipboard of our Windows machine, not of our Ubuntu machine, our Windows, because that's what we're going to use. We're going to use RDP, Remote Desktop Protocol, to be able to remote into that machine and be able to use it and do all of our network analysis. So I'll connect to this machine. So when you set up your machine, you'll create a user. Just remember what that username is, and then remember the password that you set for it. And then just click continue. Now while that's loading, I'm going to explain what we're going to do. So firstly, we're going to go to Wireshark's website and we're going to download Wireshark. We're going to install Wireshark, and then we're going to have a quick look at the network traffic that's going through, and then we're going to narrow down into ICMP traffic between our machines. We're going to set up a firewall on our Ubuntu server and observe what happens when we do that to prevent ping, and then we're going to look at our SSH traffic. So we're going to SSH into our Ubuntu machine and see what that looks like in Wireshark. Then we're going to look at DHCP and see how we renew our IP address. And then finally, we're going to look at DNS and RDP, which are very simple protocols but very important. So first, let's go to Microsoft Edge. It will ask us whether we want to start without our data. Yes. We don't want to do any of that. So we will go to google.com, and here we'll type in Wireshark. We'll just go straight to download. And click Windows Installer. So Wireshark is a network protocol analyzer. What it does is it breaks down network traffic. So it kind of gets the traffic from your network interface card, and it routes it through this program, and this program then displays it in kind of like human readable format and breaks it down into the different layers of the OSI model, and also separates all the traffic out into its different protocols and purposes for us. So it just makes it easier for us to be able to sort through the network traffic on our network and to be able to understand what's going on the wire. So we'll open the file, we'll click next, we'll click noted, click next. I like to make a desktop icon, so I'll click that, and then next, next. We'll have to download npcap and install that. So let that happen. Next, and then we won't do USB pcap, install that. So this will then install. Then we'll need to agree to the nmap stuff. Next, click finish, and then this will finish down installing Wireshark. Click next, and finish. There you have Wireshark is now installed on your Windows virtual machine. So then now the next thing we need to do is we need to open it. And as you can see here, this is our Ethernet adapter, the one that's actually connected to the network and the internet. And then these little lines here are it just shows you the traffic that's going through this Ethernet adapter. Now to start a traffic capture, you just need to click the blue fin up here. And as you can see, it's starting to do stuff. So let's get this bigger. So here we have three main panels. So this panel here is just our web traffic, and it's keeping up with it. You can let it stick to the bottom by clicking this button here, or if you want to just stop it from doing that and just kind of like go up and down on the traffic, you can do that. Down in this panel we have the specific packet that we've captured. So I'll just click a packet, just a random packet, and it will show what it is in the physical, the data link, the IP, and then the transport layer protocols. We'll go through the headers of each packet and show what's in them. And then here we have a hexadecimal representation of those headers. So instead of showing us all in binary what the packet is, it will show us in hexadecimal what it is, and then kind of like what the data is at the end. So if you want to have a look a little bit more, you can look at the different things here. So now for our purposes, what we're going to do is we're going to go up to apply filter up here. This search bar here is actually a display filter, and it will help us to filter out other traffic and only focus on one bit of traffic. So what we're going to do is we're going to look for ICMP and press enter. And as we see, we don't have any ICMP traffic here at the moment. So we're going to generate some of this traffic for us between us and our other machine. So we'll go down to the search bar down the bottom and type in PowerShell. Move this over here so we can see what's happening. So what we're going to do is type in ping 10.0.0.5. Let me just check that. Yeah, 10.0.0.5. It will ping, and we've got a reply. So as you can see in our Wireshark, we have generated some traffic here. What we can see is firstly that we have a source and a destination. The source is us, that's our IP address, and this is the destination. and then that's our request. So this is the request that we sent using ICMP in ping, and then we received a reply from the machine. So the source is the destination of the first packet, and then we've received a reply to our machine, and that's a reply. So that's kind of how ping works. So the purpose of using ICMP is to be able to troubleshoot network problems, and to be able to know whether a host is alive, whether there's connectivity issues, whether there's a firewall that could be preventing connection, all of that kind of stuff. So what we're going to do next is we're going to try to ping Google. So we're going to ping google.com. And as you can see, it's a completely different IP address that we're actually pinging. And so this is the address to one of Google's servers that's probably closest to this machine, and it's giving us a reply saying, yep, I'm alive, I'm here, and I can hear you, and I'm receiving your request. All right, next thing we're going to do is we're going to initiate a ping that is perpetual. So we'll do a -t at the end, and that will be to our Ubuntu machine. Now what we're going to do in Azure is actually create a network security rule that turns on a firewall to stop this from actually going through. So we'll go to our Ubuntu machine. What we'll do is actually we'll go to our resource groups, go to Wireshark, and we'll go to this Ubuntu NSG. So this is our network security group. Now what we'll do is we'll go to inbound security rules. So this sets the rules for any inbound traffic that's coming to us. We'll add a new rule. So source any, port ranges any, destination any. We'll select ICMP. We will deny it, and we'll set the priority to 200. So we want to make sure that this is the first rule, and that it's a priority that this doesn't happen. So we'll add this rule. So it's creating the security rule, and it will deploy in a second. So as we can see here, this is continually replying, and as soon as the security rule kicks in, we will see that that request timing out. And as you can see now, the request is timed out. Now the difference with Wireshark now is that all we see before, we saw 10.0.4 and then 10.0.0.5. So the sources have been switching because we're sending a request and receiving a reply. But here we see, instead of getting a reply, we're just sending requests. As you can see, request, 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 request. And it's because our ping is actually getting dropped. As soon as it hits the other machine, it's getting dropped and not being allowed to come through. And that's kind of how a firewall works. It analyzes traffic and decides whether that traffic is legitimate and allowed to be in this network. If it's not, then it just drops it, and it's times out. So now we're going to undo what we just did. Go to our security group, and instead of denying, we'll just allow. We'll save that. It'll update it. And this takes a little bit for it to kind of like click over once we go back to our machine. And now we see that there's been all the replies from our request. So now the traffic is open again, and now we can see everything that we can now that the traffic's open again, we can see that it's going through, and we're receiving a reply back that the machine's alive and that we can communicate. Alright, so the next thing we're going to look at is SSH. So we'll go up to here, to our filter, get rid of this, and we'll type in SSH. Type enter. As we can see, there's no traffic here. So the first thing we need to do is type in to our PowerShell, we need to go SSH, the username of our machine, so when we're SSHing into a machine, the syntax is SSH and then the username of the user that we want to log in as at the IP address or domain name of the machine, and then you hit enter. It will ask you if you want a fingerprint. You say yes. Then it will ask you for a password. As you can see here, we have the starting of some traffic. So now I've logged into the machine, and it will constantly send traffic back and forth to maintain the connection. So when you log into SSH, the first thing it will do is it will see if you can exchange some login keys. And what login keys do is just eliminate the need to be able to use a password. But if that doesn't exist, then you have to provide a password. So here we have the user. So what we can do is we can type in who am I, lab user. The beauty of SSH compared to things like Telnet is that SSH is actually secure, and so the traffic that's sent is encrypted. So if we want to have a look at what's actually the commands that I'm sending, we won't actually be able to see what it is. So as you can see, the encryption, it shows you what kind of encryption it has, and then you won't be able to actually understand what's going on here. So this part is this, and we can't actually understand that, and that's the point of SSH. That it's a secure shell protocol. So let's create a file. Text. So as we can see, we've created a file there for us, and it continues showing where the info is, whether it's coming from a client or coming from the server, where that traffic is coming from. To exit SSH, you just type exit, press enter, and it closes the connection. The next thing we want to look at is DHCP traffic. And for that, the command we're going to run is ipconfig/renew. So that will send a request to renew our IP address and make sure that we are assigned the correct IP address for our part in the network. And as you can see, it's simply sent a request, and then the DHCP has sent an acknowledgement and said, okay, this is your information. So So we see here, if we open up our packet, we see there's DHCP server identifier, and it tells us the IP address of the DHCP server, and that it's an acknowledgement, and then how much renewal time we have. Length is 4. We have infinite renewal time, so that means that we will always have this IP address for as long as this machine exists. That's a really simple one to have a look at. The next one we're going to look at is DNS. And as you can see here, we have heaps of DNS traffic. That's because our computer is constantly querying Microsoft, and it's constantly querying the internet for information to be able to find where things are and how to communicate to other things. And so what we're going to do is we're going to do an NS lookup of Google. And we'll create some traffic like that. Let me just renew this. And so as you can see, what we do is we just performed a name server lookup for Google, and it's given us a list of IP addresses, IPv6 and IPv4 addresses, and here in Wireshark we see that our source, which is us, has sent a query saying, hey, what's the IP address for Google? And the DNS server has sent a reply saying this is an IP address for Google, and it sent us 1, 2, 3, 4, 5, 6, 7, 8, 9 addresses, and we've received 1, 2, 3, 4, 5, 6, 7, 8, 9 responses from the DNS server. And so this is just showing us where what the actual address is for the Google servers when we want to reach out to Google, where we're actually reaching out to. And as we can see from, if I make this bigger, there's more information about the addresses. So like google.com.gobbledygook, internalcloudapp.net. That's one of the name servers that Google owns, and so these are all just hosts that when we reach out to the DNS server to say, hey, where's google.com, it sends a response to say these are all the stuff that we have on record for you to be able to connect to google.com. And now for the final one is our RDP. So I'm going to clear the screen. Now for this one, we don't write RDP, we actually write tcp.port, TCP port equals 3389. 3389 is the port number of, I scrolled. Is the port number for RDP. We don't actually have to do anything, but because we are using RDP at the moment. So remote desktop protocol is the protocol that we're using to be able to, for me, sitting in my basement here in Australia, to connect to my East US virtual machine that's out there in Washington. And so this is giving me all of the traffic. As you can see, it's just producing traffic, and I'm sitting here not doing anything, but it's producing traffic because I'm making traffic. So as I shut things, or if I move things around like this, I'm producing traffic over RDP. As you can see, application data there. There's also lots of TCP connections that are being established and maintained, as you can see. and that's just making sure that I'm maintaining connection between my computer and the virtual machine and across the internet. So as you can see, this is a really cool thing to do. I would encourage you to have a look at Wireshark and play around with it yourself and see what you can do with it. And with that said, thanks for watching. If you really like this video, please click the like button, and remember to shut down and delete all your Azure infrastructure so you don't get a crazy bill at the end of the week / month / year, because that would be the worst thing that could happen, is that you left this stuff running and that it would be all it would just charge you crazy amounts. So remember to delete that. Anyways, I'll see you in another video. Bye.